Now, continuing from our last video, we saw how a quadratic equation should be solved. That's under factorization, how to factorize a quadratic equation. Now, continuing from there, we're going to be looking at this question. Now, if you look at this question, it's a bit different from that last question. This question has something different in it. So, how do you solve a quadratic equation that has 4 terms? Now when you look at this, we have our many terms, 1 2 3 4, and remember I said the quadratic equation should have three terms, but this time around we are having a quadratic equation having 4 terms. So how do we solve something like this? Now look at the equation very well. When you close this here, what are you seeing here? You are seeing 3 terms. Is that not so? This is how a quadratic equation should look like. So we are going to solve these parts first before we come to this brother here. You understand? So now if you look at this quadratic equation, it is a very unique type of quadratic equation which we call a perfect square equation. And what is the law of perfect square? The law of perfect square tells us that there are 3 laws that governs there are 2 laws that governs a perfect square a quadratic equation. How do you identify that a quadratic equation is a perfect square? Number 1 law says that the first term and the last term must be perfect squares, and you see that the first term is a square, the last term is a square. They must be perfect square. Like 4, the last term can be 4, can be 9, can be 16, can be 25, can be 36, as long as it is a perfect square. Then the middle term must be twice the product of the first 2 terms. You understand? The middle term must be twice the product, x times a, of the first and the last term. So now let's solve this question. Now since you know that this is a perfect square, and when you solve this, because when you solve it like the way I taught you guys, you are going to arrive at x minus a squared. This is how the answer will be, because when you open this bracket you will still get this question, because in expression of factorizing an expression, it is reversible. In our JS3, you know that you did factorization, and your teacher will tell you that factorizing an expression, it is what? Reversible. So when you reverse this, or when you solve this question, you will get this, and when you solve this, you will get this. Do you understand? So this is how our answer will be. We are not going to be having minus b squared. Did you see how straight we went? We didn't have to go any longer. So this is how your question will now be. So from here now you can now solve. Now when you look at this question, it looks like a very it looks like something we know in secondary school. Were you taught something like this? When you see a squared minus b squared, it's the same thing as saying a plus b and a minus b. Is this not how this thing look like? This a squared and b squared, is this not how it looks like? Because you are seeing a minus sign here. So this is how it looks like. So it means that this is following this rule. Do you understand? This question here is following what? This rule. So we are going to be using this rule to solve this. Is that clear? So let's use that rule to solve this question now. So let's use that rule. So we are going to be having, when we open this, we're going to be having, because this is your a and this is your b, so we're going to be having x minus a plus b, because we are bringing this close bracket. We're going to be having x minus a minus b is equal to 0. So since you are having, remember you now have your 2 terms. You see, you are now having your what? Your 2 brackets. So what do? You just come here and you equate this by 0, and you come here and you equate this by 0. Very simple. This question is even the simplest. So what do? Since you are looking for x, when this minus a crosses over, it becomes plus a, and when this plus b comes over, it becomes minus b. Now when you now have x is equal to, when this crosses over, it becomes plus a, and when this crosses over, it becomes plus b. So your x now is equal to a minus b and what? Or a plus b. This is your x. That's all. This is how this question should be solved. Very simple. Is that clear? So let's go to the next question. Now look at this question. The third question says x squared plus open bracket ab all over c minus c all over ab close the bracket minus x minus 1 is equal to 0. Now how do you solve this question? This question is very, very easy. It's just that some of us will see it and you're already scared. You shouldn't be scared of this kind of question. Now when you look at this very, very well, you follow. You see, one thing with mathematics is that you learn to follow rule. Learn to follow rule in mathematics. Now what do you do now? You know that normally in our question you shouldn't see a bracket. Is that not so? The bracket should come while you are solving it, not in the equation. So what do? You use this x to open your bracket, because this x is a bit closer to the what? To the bracket. So you use your x there to open the bracket. So when you use your x, you are going to be having x plus what? AB all over cx, because this x is multiplying this, minus c all over ab x minus 1 is equal to 0. Did you see that directly we have gotten our binomial? Directly we have gotten what? Our binomial. So you are going to be having something like this, your two binomials. Did you see it? Yes, your first term and your second term at that point there. So let's look at what do you do now. Remember I said this is where you now what? Bring out what is common. This is where you now what? Factorize. So when you want to factorize what is common here? X is common. So when you bring out x here, you are going to be having left with 1x plus ab all over c. Now minus, how do you now know what is common in this bracket? Since you don't have x here and you have x here, you don't have x here, that means x is not common. So what is common here? Now we have c all over ab and you have 1 there. It shows that c all over ab is the common factor. How do you know that c all over ab is the common term there? Now look at this. When you multiply c all over ab by its inverse, you are going to be having, when you multiply c all over ab by its inverse, which will be ab all over c, you're going to be getting 1. Why? Because ab we cancel ab one time, c we cancel c one time. That is how you got this one here. Did you get it? That is how you got this one here. So we're going to be having c all over ab as our common term. So when you bring it out, you're going to be having c all over ab, we cancel c all over ab. So x will be x here minus what? ab all over c, because when you multiply this, you are still going to get 1. When you open this bracket, you are going to be getting what? 1 is equal to what? 0. Are you following? So knowing that, let's solve. So you now, I told you what is in this bracket. Sorry, this is supposed to be plus, because minus we cancel, minus will be what? Plus, because what is in the bracket must be exactly to what is in this bracket here. So you are now going to be saying x, you marry these two together, x minus c all over ab is equal to 0, and x plus ab all over c is equal to what? 0. So when this comes here, it becomes x is equal to, when this crosses over, it becomes c all over ab, or when this comes here, it becomes ab minus ab all over c. So your x is c all over ab or minus ab all over c. This is your answer for the dot question, and this is how you factorize a quadratic equation. Very, very simple. I trust that God will grant you the wisdom and understanding to comprehend this type or this method of solving quadratic equation. So in our next video, we are going to be looking at the formula method of the quadratic equation. Thank you very much for watching. See you in our next class.